In exercise 10, we're told that Fred is given a rectangular piece of paper. The length of Fred's paper is represented by the expression 2x minus 6, and the width is represented by the expression 3x minus 5. What is the total area of the paper? Area is length times width, and so we take the length and the width and we multiply them together. Remember to use the distributive property and combine like terms carefully. Then we find the area of the paper. Notice that choice 2 matches the area that we came up with, and so choice 2 is our answer. Exercise 11 has several options as to how we could solve this problem. We're given 2 points, 3, 11, negative 2, 1, and we're told that they're on a line. We want to know which of the given points is also on the line. Perhaps the easiest way to solve this problem would be to construct a graph. Use the graph paper in the back of the exam to set up a graph, plot the 2 points, and connect them with a line. Take a look at the given choices. Which point is on the line? This one right here, 2, 9. And so 2, 9 is also on the graph. There are other options we could do. We could take some time and write an equation. You could write the equation either by putting the 2 points, 3, 11, and negative 2, 1 in a list and spreadsheet and doing a linear regression to find y equals 2x plus 5. Or you could take the 2 points, calculate the slope using the slope formula, and then substitute them into the y equals mx plus b to find the y-intercept and get the equation y equals 2x plus 5. Either way, you get the same equation, and then you can proceed. Which point is on the graph? Well, it's the point which makes the equation true. Substitute in the points 2, 1, 2, 4, 2, 6, and 2, 9 into y equals 2x plus 5 and see which one causes the equation to be true. Again, it's choice 4, the point 2, 9. That's the point that's also on the graph. One other option you do have is you could take the equation y equals 2x plus 5, put it into your graphing calculator, and look in the table of values. Look where x is 2 and see what the corresponding y value is. 2, 9. Therefore, choice 4, 2, 9, is the point that's also on the graph. In exercise 12, we're given 2 functions, f of x and g of x, and we're asked to compare them. G of x equals x squared, the quadratic parent function. F of x equals 3 times x minus 2 squared plus 1. In this case, there's some stretching and some shifting going on. The leading coefficient became larger, which means the graph is steeper or narrower than the original. The x minus 2 squared indicates that the graph is moving to the right 2, and the plus 1 indicates that the graph is moving up 1. Read the choices carefully. The graph of f of x is narrower than the graph of g of x, that's true, and its vertex is moved to the right 2 units and up 1 unit. So choice 2 is our answer. If we weren't sure about the shifting, we could always look at the graphs. Graph the original, g of x equals x squared, and graph the new function, f of x equals 3 times x minus 2 squared plus 1. Make observations about the graph. Notice the new red graph is narrower or steeper than the original blue graph, and we can trace the coordinates of the vertex as moving to the right 2 and up 1. Again, we find that choice 2 is our answer. In exercise 13, Connor is attending the town carnival. The price of admission is $4.50, and each ride costs 79 cents extra. He can spend at most $16, and we want to write an inequality that can be used to solve for r, the number of rides that Connor can go on. They also ask what is the maximum number of rides that he can go on. So let's organize the information that we have. Admission is $4.50. That's the fixed cost. The rides cost 79 cents each. That's the variable cost. The variable r will be attached to this amount. He must spend at most $16. At most indicates less than or equal to. We write the inequality 450 plus 0.79r is less than or equal to 16. That's the inequality that we can use to solve for r. Now, we solve that inequality and we find that R is less than or equal to 14.55 rides. How many rides can he go on? Well, he can go on 14.55 or fewer. He doesn't have enough money to go on 15 rides, so don't be tempted to round up. The most rides he can go on is 14. Look at the choices carefully, and we see that the inequality in the number of rides that we want is choice 3. In exercise 14, Corinne is planning a trip to the beach and she's looking at the daily high temperature. She wants a destination that has a high median temperature and a small interquartile range. Remember, a small interquartile range means that the temperature doesn't vary all that much. She constructed box plots of the temperatures for each of the destinations she's including. Which destination has a median temperature above 80 degrees and the smallest interquartile range? Let's remember what these mean. First of all, in the box plot, the median is given by the line in the middle of the box. The width of the box is the interquartile range. The wider the box, the more variation in the temperature, and the narrower the box, the less variation in the temperature. Now let's examine each of her criteria. First, she wants a median temperature above 80 degrees. Let's take a look at each of the choices. Ocean Beach has a median temperature that is under 80 degrees, so that's not an option. Whispering Palms has a median temperature above 85, so that looks like a fair choice. Serene Shores has a median temperature that's less than 80 degrees, so that's not a choice. And Pelican Beach has a median temperature right about 85, so that's one of her options. Now we want to choose the one that has the lowest interquartile range, or the smallest interquartile range. We look at the width of the box. Which one is the narrowest? Pelican Beach. Pelican Beach has a median temperature that's both above 80 degrees and has the smallest interquartile range. And so choice 4, Pelican Beach, is our answer. Problem 15 tells us that some banks charge a fee on savings accounts that are left inactive for an extended period of time. That means if you have a savings account at a bank and you don't use it, you don't put money in, and you don't take money out, they might start charging you a fee. For a particular account, the bank uses the equation y equals 5,000 times 0.98 to the x. Y represents the value of the account, and x represents the number of years that the account has been inactive. We're asked, what is the y-intercept of this equation, and what does it represent? You probably recognize this as an exponential function of the form y equals a times b to the x. In an exponential function, a represents the y-intercept, or the initial amount. B represents the factor. Which of the following is the y-intercept? Well, in our equation, y equals 5,000 times 0.98 to the x. 5,000 is the y-intercept. 0.98 is the factor. Remember, 0.98 means that 98% of the money remains and 2% is taken away every year. The y-intercept is 5,000. What does it represent? The amount of money in the bank initially. And so go through the choices carefully, and we see that choice 3 is the amount of money in the bank initially, the y-intercept, $5,000. In exercise 16, we're given the equation for the volume of a cylinder, V equals pi r squared h. They're asking us to find the positive value of r in terms of h and v. That means we're solving for r, and h and v will be on the other side of the equation. Take a look at the equation carefully. Along with the r squared, we have multiplied pi and h. Divide both sides by pi and h so that they cancel out on the right, and we're left with v over pi h equals r squared. We haven't isolated r yet. We have r squared. The inverse of squaring something is taking the square root, so we take the square root of both sides. R equals the square root of v over pi h. We're asked what the positive value of r is, so that's the positive square root of v over pi h. Look at the choices carefully and see that choice 1 is the answer. In exercise 17, we're given the equation x squared plus 6x minus 7 equals 0. Which choice has the same solutions? There are several ways you could do this, and we'll take a look at a couple of them. The first is to take the given equation and try to make it look like the ones in the choices. It looks like those equations are in vertex form, and so I can use the process of completing the square in order to do that. I have x plus 3 squared minus 16 equals 0. Add 16 to both sides so it matches the choices, and I notice that choice 4 is the one that matches. Because these are equivalent equations, they must have the same solutions. Another option would be to take the original equation and solve it. You could solve it by factoring, completing the square, or using the quadratic formula. Either way, you'll find x equals negative 7 and x equals 1. Now take those solutions and substitute them into the given choices. If the equation is true, then you know it's a solution to that equation. When I substitute those values in, I see that choice 4, x plus 3 squared equals 16, is made true for both of those solutions, x equals negative 7 and x equals 1, which means they're also solutions to that equation. So again, choice 4 is our answer. Another option would be to take each of the equations, set them equal to 0, and then substitute the 0 for a y equals. Graph each of the equations in your graphing calculator and compare the table of values. When I do that, and I look at the table for the original, I notice that the table of values for equation number 4 is the same. Because they have the same input and output table, the equations must be equivalent, and therefore they must have the same solutions. Again, choice 4 is the answer. One other option would be to take each of the choices, multiply them out, and try to make them look like x squared plus 6x minus 7 equals 0. If you were to do that, you would find that choice 4, once again, was the solution, and therefore it has the same solution as the original equation.